Good evening. My name is Mshibudini Tabata, and tonight I'm going to be presenting on Tpg3700 Design Project. The topic of the project is upgrading a gravel road or a road that has reached its end life to a standard 4-lane divided road. Now, the introduction. The M77 begins in Moroka, Soweto, at a junction with the M68. It travels for 10 kilometers north into Jabavu. It reaches the western terminus of the M79 here, as well as Dobsonville, where it joins the M72 and the western terminus of the M70 to escape Soweto and conclude at a junction with the R41 in Roodepoort in the Creswell Park neighborhood south of the town center. Now, the need for the refurbishment of the road is because this road is the busiest and has significant traffic levels, and then it is being renovated to suit the high traffic volumes. The project was necessitated by growing traffic loads, diminishing levels of service on the road, and the pavement of the old road reaching the end of its useful life. The investment in the project indicates SANRAL's appreciation of the importance of having good roads. This is also to support economic activity and growth by ensuring the safe and efficient movement of people and products through suitable infrastructure. The project comprises converting the existing 3.8 kilometers 2-lane undivided road into a 4-lane divided road in order to improve traffic flow throughout the route. Now, my next slide addresses the estimated present traffic. A traffic study was conducted before from the information that was obtained from the municipality, which assisted in the design of the existing pavement structure. Based on an average daily traffic of 1,200 vehicles per day and an analysis period of 20 years, the recommended class for this particular road is ES3. Now, the next slide talks about the design standards or guidelines that were used during the course of this report, during the compilation of this report, The general accepted documentation standards such as the South African National Standards, your call to the NRA, G2 Design Manual, TRH4, TRH17, SANRAL Manual, and UTG1 are adopted to perform road design. Geometric design projects for highways, an introduction by John G. Schoon. Geometric design of rural roads, TRH17 by the Department of Transport, South Africa. The Geometric Design Manual, SANRAL, by the Republic of South Africa. The Geometric Design Manuals, SANRAL. The Structural Design of Flexible Pavements for Interurban and Rural Roads, TRH4 of 1996. Guidelines for the Geometric Design of Urban Arterial Roads, UTG1, by the Department of Transport, South Africa. The Drainage Manual, 6th edition, SANRAL, South Africa. And lastly, the SANRAL Land Acquisition Guidelines for Consulting Engineers, Revision 6 of 2017 by SANRAL, South Africa. Now, moving to the brief overview of the adopted geometric design software. For this particular project, I adopted RoadMate for the geometric design. The comprehensive suite provides integrated civil infrastructure design, analysis, and documentation functionality, including advanced industry drawing file compatibility. The software allows for DTM creation and manipulation, advanced survey calculations, bulk earthworks, roads, heavyweight pipes design and analysis functionality for sewer, storm and water networks, quantity generation, production, drawing generation, 2 or 3D CAD, realistic model, rendered video creation, and BMI export. Now moving to the pavement design calculations. The number of vehicles per lane per day is 1,200, and the road category for this particular road is category B. The equivalent design traffic was calculated to 1,627,632 thousand E80s. Therefore, the needed bearing capacity of pavement is between 1 and 3 million standard axles. The pavement class is ES3, and for single axle load, the load of 76 kilonewtons, and the relative damage opponent N is equals to 4. So therefore, ADE was calculated to 97.8 cumulative EOEs to 11 million. The geometric capacity was found to be 1,727.2. Sorry. Now, moving to my next slide, the pavement design base layer selection. The base layer selection was done with guidance of TRH4, and also the CBR category was as per table 22 of TRH4. Now for the subgrade selection also, I referred to TRH4. Now for the adopted pavement design, the different layers of the road, the surfacing, the description thereof is the continuous medium grade of a 40 millimeter thickness, the base layer of 150 millimeters, sub-base layer 1000 kilopascals at 97% mod Ashton density, and is also at 150 millimeters thickness. The selected layer of also 150 millimeters, subgrade layer also 150 millimeters. Now the next slide addresses the vertical curve calculations. The design speed of this particular road was 80 kilometers per hour. So therefore the minimum K value is 33, adopt 16 for the K value. The length of the curve was calculated to be 193.71, and then 193.7 is greater than 114 meters, which is the minimum curve length for a 80 kilometers per hour design speed. Therefore, it is okay. Now, this allows for the calculation of the beginning of the vertical curve, at the end of the vertical curve, the elevation of the PVI, the elevation of the BVC, and the elevation of the EVC. The next few slides are screenshots from the software. This particular slide is of a screenshot for the road delineation from cadastral and survey. The next screenshot is converting polylines 2D into a road stake line. And then the next screenshot is of a stake line curve and point of intersection adjustment. The next screenshot is horizontal layout. The division of the road is to be adjusted on the road section template. The next screenshot is selection of contours from a TIN surface, and the next screenshot is the formation thereof. The next screenshot is writing the TIN surface for later uploading onto the road layout. The next screenshot is a vertical point of intersection adjustment. The next screenshot is when inputting the new VPI data. Then this next screenshot is whereby the drawing of the cross section takes place. And my next slide is the mesh hole diagram. The graph is plotted against the cumulative volume and the chainage. This next slide is the Excel sheet for the vertical curve calculations. The next slide is a typical view of the cross-section. The next slide is the road setting out data. I have come to the end of the presentation. Thank you.